What's up, Tube? Welcome to Guido's Chop Shop, the second best Gel Blaster channel on the tubes. And today what I'm going to do, it's not just today actually, it's probably going to be a project that goes for a little while. I'm going to do something a little bit different. It may not initially seem like it's Gel Blaster related, but it will be. Trust me, it will be Gel Blaster related by the end of it. Some of you may notice that in some of my videos recently and in some of my Twitch streams, there's been a bit of a whirring in the background, a bit of background noise. I have gotten myself a 3D printer in the last couple of months, and I have been enjoying printing various things with it. So my next project is going to be a bit of a 3D printing project, and yeah, well, I don't know, I don't know why I continue with this facade like it's some sort of mystery what I'm doing, because you guys have already seen the thumbnail and the video title, so you probably know what's going on anyway. But yeah, here we go. Let's start printing. Alright, after that 3D printing marathon, I now have all of this. And I should point out, full credit to the original designer of these files from Thingiverse, Mark W. Tech. I will put a link to that in the description. I did not design this. I merely took the design and printed it, and I am going to make my own little, touches. Put a little bit of a Guido spin on this as well by the end of it. So this is where I'm at so far. Let me just make this pile of parts a bit tidier, and we'll continue on. Alright, here are all the bits, or at least all of the 3D printed bits. There's obviously going to require hardware and electronics as well, which is not here yet, but it's definitely been a good learning project for me with my 3D printer, because I'm still new to this. I haven't 3D printed before, and it's pretty amazing stuff. I love it. TPU is another thing that I've just started. I've never printed TPU before, so that's a cool thing as well. It's a rubbery, soft sort of print stuff, so that's cool. That's a learning experience as well, learning to print with these different materials. All good fun. Alright, I guess the next thing is to start putting it together. Oh, there's motors, servo motors. I have a bag full of servo motors here. So that's a little servo motors. I have a bag full of these. So yeah, I think I'll start with those, or all these have got to go into these little carriers, and also on the bottom of these little carriers there is a circle which is going to hold a bearing, so I'm going to have to press a bearing into there as well, and screws, lots of screws. The original design that Mark W came up with had American non-metric size screws, so I've just gone with M3s. Hope for the best, because I don't understand non-metric. But yeah, M3s is what I've bought bags of, so hopefully that will work for me. Let's go. Okay, first things first, these tiny little circles here are bearing spaces, so the screw goes through the middle of this, and then that goes into the bearing. Now the M3 screw seems to be a fairly nice fit in there, which is good, but these don't fit through the bearing. And the reason is because during the printing process, as the printer comes around and goes back to do these circles, where it starts and ends, it leaves a little blob. So let me just zoom in so I can show you that. Alright, so you might be able to see just on this edge here. I mean, keeping in mind this is quite small. This is my finger. These things are smaller than my finger. The little blob is microscopic, but maybe not microscopic, but it is maybe a millimeter or less, and it's just enough to keep it from sliding in that. So I'm going to have to finish that by either filing that little blob down, or I'm just going to heat it up and squash it in, which might be the more likely of the two. Okay, so I found that the best way to do this is to heat these bearings up with a torch, with a heat gun, and then once they're nice and hot, push the servo mount onto them, and then push the little screw cap into them, like so. Get them seated in there nice and flush, and then while they're... Alright, so I've done that 18 times. Some of them worked better than others. There were a few, this one in particular got a bit I don't know, I just didn't want to go in flush, and then the heat warped the part a little bit. I think it should be fine. Most of these appear to be fine. So with these spacers, I pushed a couple in while the bearings were still hot, and they kind of worked out okay, but then some of them I ended up melting a bit, so I've decided that I'm just going to go with the mechanical filing of them. Slow, but it'll get the job done. Alright, so after destroying probably about 3 of these little bearing center spacer things, I decided that I'd just go back to the drawing board and redesign my own center spacer. Just slight changes to it. The OD on the spacer was bigger than the ID of the bearing, and I don't know if I got this a slightly different set of bearings to what was specified in the design, or whether or not it was just like, I don't know, printing tolerances or something. I ended up just designing my own, and just modifying the design slightly from just knocking it down a bit, and after that, done. Got them all in, looking pretty sweet. Happy with that. Now these little containers here are to house the servo motors. So basically, how does this goes in here, with the bearing there being opposite that. So this wire goes through here, and if all the tolerances are correct, this should fit in. Try not to pinch my wire too much in there. And make sure it goes in square. Alright, beautiful. Lovely, tell your mother. Oh, that's so satisfying. Alright, sweet. Now I've got to do that 18 times. Don't worry, I'm not going to film the whole 18 times. Or maybe I will. Just to keep you guessing. No. The trick here is you got to get these things in. They got to go in square, but you've also got to push them in with enough angle that the wire doesn't get crimped on the way in. But you know, it's pretty quick. Get one out of the pack. Feed the wire in. Make sure the wire doesn't get crimped. And then try to bring the thing around square. And push it down square. Nice. Alright, I'm just going to do this for a while. In case you were wondering, these steppers are the MG996R 180 degree stepper motors. So they're pretty fairly generic sort of things, pretty cheap, relatively easy to get, not expensive. That's the main thing, right? Okay, so I'll need one of these, one of these, one of these, one of these. No, that's the same. One of these. All the same. These are the same. These are the same piece, but one's printed that way and one's printed that way. So there, one of those, one of those. One of these. 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 Two of these. And two of these. Alright, let's go. Okay, so I just realised before I go and do this 18 times, or after I've done it 18 times and then realise and then have to go back and do it, I just realised there's where this bearing spacer is, there's actually I'm supposed to put a screw through there from the inside here that goes hold on, get a screwdriver on it. I need to put a screw, good work, through this bearing spacer from the inside, because these guys have got a screw on from the outside, and then I need a nut on here. Now, I ordered M3 nylock nuts. In hindsight, I probably could have got away without the nylock. Maybe I could have just gone with a regular nut. But gotta do this, turn that up there so that these guys have their hinge before I put the servo motor in here, because once you put the servo motor in there, it's hard to get the screw in. But yeah, alright, so that is what I got to do 18 times. What I'm going to do here, I'm just going to clean this bench up a little bit so I've got more space for working on, because at the moment there's just a big pile of things. Okay, so for each leg now, I've got to prep 3 servo cases with the screws and the bearing centers. Now I've got what have I got here? I've got M3 screws. I had to convert them to M3, and some, because the original hardware list was not in metric. Now some of these bearing spacers I've found, I just have to run a drill through to just to get the clearance, and it's a bit tricky because they are in a bearing, so they spin. So I found I've got like a 3mm drill bit, and I run it in reverse just so it doesn't grab and spin, and usually hold it with like a pair of pliers or something, and run that through gently so that it, try not to take my finger off. Usually I would hold this with a pair of pliers, but it's difficult on camera to hold it with a pair of pliers and drill and all that sort of stuff, but yeah, so that's what I do there. Just run the drill in reverse, because it's just enough to sort of clearance out that that hole so that it's perfect for the screw, because some of the 3D printing tolerances might not be perfect. So the M3 screws that I got here, so I used a 3mm drill bit just to clearance those, because they are M3 screws, and I think that they're about, these particular ones are about 12mm long or something. I've got I'll put all the hardware that I used, I'll put links to it, but I think I got like 9mm, where are we? 9mm and 12mm, and I think I got some like 16mm or something. I'll put the links in the description, because I can't remember exactly the sizes. I just did the conversion from imperial to metric, and then ordered the sort of equivalent metric size in M3, because I think that was the closest that I could find. Also, I don't have a spanner small enough to grab these tiny M3 nylock nuts, so I'll just use the shifter. Oh, actually, this is worth noting, because I just did that wrong. These three have, two of them have the same plate here, but one of them has a slightly different angle plate, and you'll notice that I've got a gold one and two black ones. So the gold one actually takes the angled plate, which is this one. So if you weren't doing like some sort of different colored scheme, then it wouldn't matter. You'd just do two with a straight one and one with an angled one per leg. So I'm just gonna And again, like, I got M3 nylocks, but I don't know, I think I might have gone overkill. I'm not sure that nylocks are necessary, but I think they look good. They look, either way, whatever. I'll keep assembling these. It is also worth mentioning that if you are trying to do one of these yourself, the flat side of the 3D print, the print that was on the side that was on the bed, is the side that goes in. So if, I guess with these ones they're symmetrical, it doesn't much matter, but with the angle plate it does matter because it has a specific angle. So the bed side is in, the bed side faces in towards the servo, and that is what I'm doing here. Alright, last one for these. And then we move on. So now that I've got the plates attached, now we can put the servos in. So each servo can go into its little carrier. And then there will be screws there as well. Another thing to mention with the holes, the 3D printed holes are pretty good when printed in this direction. But when they're printed in this direction, across with the layer lines, they're not as good sometimes. So I just run through these with a 2.5mm drill bit, not the 3mm, because when I clearance the bearing ones I use the 3mm because I'm using the M3s. So I go with a 2.5 here so that the M3s can still have a bit of meat to screw into, but they can actually screw in without splitting the print down the layer lines. So that's the technique that I'm using. That's the way I'm going with that. Alright, let's chuck another servo in this one, and we'll continue on with our legs. Alright, so we've got 3 prepped. But I want to put the hats on these servos now, and before I do that I want to make sure that the servos are set in the middle position. So I've got this servo checker tester here, and so I'm just going to set the dial in the middle position and then just plug them in, and they should, if they were not in the middle position, they should move. They should move roughly to the middle position, so that's good. I'll set that in the middle, and then I'll do the same for all of them, and I'll put the hats on. Now, putting the hats on it's important that you get them in the right orientation. There is a little sprue here, and that sprue on, in my case, the 2 black ones goes at 45 degrees, and on the gold colored one it goes 90 degrees. So I'll just make sure all these are straight and centered. Okay, and then so for the gold one, the sprue on the hat is going to go 90 degrees like that, and for the other ones that go 45 degrees, you see what I mean? There's a little sprue where this was molded, injection molding mark, and it's going to go 45 degrees, and that's because the pieces that these mount to, for the 2 black ones, they mount like that, and so the holes line up in that direction. But for the angled one, because they are angled like this, the holes line up in that direction, and so this particular one, the hat has to go on 45 degrees, and then we're going to just put the M3 locking screw in there, hold those hats on. Alright, just move them off to the side for now. Gonna get 2 of these 90-degree plates and fix them together. Thus, gonna be using the 6mm screws. I've got the M3 screws here, and I haven't clearanced these holes, so they are quite tight. I could probably potentially even do this without using the nuts at all. The M3 threading into the plastic part is probably enough, but I mean I will use the Nylox just because A, I've got them, and B, just a little bit of insurance in case the printed plastic part strips. Now that I've got those tightened in, I'll just pop the nut on top there and continue like this. I'll just do that until I've got all 4 of them tightened up. Alright, now I'm going to assemble the coxer, I guess it would be. This is the mount where the first servo mounts to the body, and then this will be the first I don't know, what do you call it? Knee joint? Some sort of knee? Let's go with that. Alright, so looks like I'm going to need the slightly longer variety of screw here. Something longer than the 6mm, I think. Yep, so yeah, I'll go with that one. I'm using electric driver now because I got so tired of using the manual one, and if I'm correct, it should mount like this. So this goes in here. Yep. All right. Put it through there first. I've got a very low powered screwdriver, and it is set to the lowest torque so I don't split anything apart. I was doing them all by hand, but that gets old real quick. Even with the electric driver, it gets old real quick. Alright, now this next bit, I think I might thread that through there, goes there. See where this is going? Yes, you do. Of course you do. Okay, so I've got some small self-tappers. These are, again, I'll put the link in the description. I've forgotten exactly what size they are, but they're the only self-tappers in the whole build, and their specific purpose is to attach the leg brackets to the hats, the servo hats. And that is their one and only purpose. As far as I'm aware, I haven't come across any other use for them, but they're very small. I think they're too small for any other purpose. And they're very easy to drop on the floor. And they're not magnetic. Why are they not magnetic? I keep going to put them on the end of my screwdriver and they just fall off. I don't know where that other one went. Fortunately, I bought several hundred of them. They come in several hundred packs. And of course, we're going to put our 6mm screws in here. Which are magnetic. It's much handier. I think the 6mm ones are the ones which are used most of the time on this. There's a few occasions where the 12 and 16 or 9 and 16, whatever the other sizes are, get used, but for the most part of it, it is the 6mm. And the next one is another black one, and again we're going to use those tiny little self tappers to get in there, starting with this one. And now if I've lined all these up correctly, they should line up correctly with the hat, which they do, which is good. The only one that's different is the one that's got the 45 offset. That's the next one, which in my case is gold, because I decided to print it gold just for something different. And of course, the last, I'm just going to pop this through here. I'm sure that's probably what these holes are designed for. So the servo wires can go through there. And then I get my M3s in there. Alright, starting to look like something now. Is that a... Yeah, that's a 6. Okay. Alright, next looks like we're going to have the next... Oh, it's going to be one of these. I'm going to put one of those on because that's going to go here. And then... Yes, alright, cool. Now we're getting somewhere. It's starting to look like something. Alright. Let's start my start my M3 6mm screws into these holes, and hopefully I'll be able to just position it on and drive them in. What do I mean hopefully? Of course I will be able to. Of course I will. This is YouTube, everything always works. Nothing will ever break. If it does, we'll just edit it out. What could possibly go wrong? The good thing about this project is if I do break anything, I can just print another one. Just print another part. Got all the parts on file. I'll just reprint. Alright, got those in. Now it's time for this one. Now, I'm not sure, seems to be some space here. I'm going to use it to poke the servo wires through, so not sure if that's specifically allocated for that purpose or not, but that's what I'm going to do with it. And then they'll all probably come through here together or something. There we go. Alright, now, I think what I might try doing here is putting these screws in first, and then putting the screws in the hat. I don't know if that's gonna be easier or harder, or I don't know, let's go with this. Make sure I got them all lined up before I tighten them in fully. Alright, yep, looks good. Alright, now my theory is that now that that's in, I should be able to get to the screw holes in this hat a bit easier. I always manage to drop these tiny little screws all over the floor, so anything I can do to make it easier is going to be good, I guess. That seems to work. Seems to work alright. Alright, from now on that's what I'm doing. All these screws in, and then that's when it really starts to get interesting. It's starting to look pretty cool though, isn't it? Like, I don't know, maybe it's just me, but it's starting to look a bit like something robotic. Now the next bits are kind of cool. This whole thing's kind of cool, to be honest. So we got these bits and one of these and one of these. One of these, alright. Alright. Screw these bits into this bit. Now I could probably put a longer screw in this. I'm just using the short ones still. But I mean, the hole does go all the way through this. Probably not necessary. Weight reduction. It was all part of my plan. I really like the appearance of this. The sort of scaffolding look. Very industrial. Very structural. I don't know if I need to put a long one through here, but I'm gonna. Nah, actually, I'll put a short one. I've got more short ones. Screw decisions. Which size screw should I use? Biggest decision I'll make today. Alright, and now, one of my favourite bits is the TPU foot. This one does actually require a long screw. The longest one, the 16mm one, goes all the way through. All the way through the foot, and then there's a nut on the other side. Which incidentally it turns out to be a 5.5mm nut, and for the life of me I do not have a 5.5mm spanner. I did find a 5.5mm socket, which would work alright in this instance, where you can get a socket onto it, but like in these bits here where it's a bit tight, you can't get a socket in there, so not much point. Just use the thumb detecting nut fucker. I mean, these don't have to be super tight. They're only holding the little rubber foot on, and they're not a lock anyway, so boom. Alright, another little bit here. We got to get this piece on here, I believe, like that. And now, ooh, it's starting to come together, starting to look like something. Alright, so 4 screws in there. Alright, so I'm using the medium sized screws on these. So I've got to go through this plate all the way through, and then all the way into this piece that the servo motor holder. There is a lot of screws. Probably the most probably the most screws I've had in my life. Alright, did I get that on right? I think I did. I think I did. That looks right. Okay. Four more screws and this leg is done. Alright. Might get these screws started in the leg first so they don't slip off all the time. And because you're basically driving a thread into both parts, you sort of got to have them nice and close and tight, so otherwise they want to push each other away. Thank goodness there's only 6 of these legs. Good for you. I have the power of editing. Alright. Oh man. That looks badass. I gotta do it. I can't help myself. That is too cool. Rinse and repeat that process 6 times and you have 5 arms. Why do I only have 5 arms? Oh. 6 arms. Rinse and repeat 6 times. Look at this crazy, beautiful monstrosity. Doesn't it look amazing? Alright, well, you know what's next. Mounting all of these arms onto a body. So, here's the body plate. 2 body plates, and these, one by one, gonna screw onto here. Now I'm hoping they use the medium-sized screws because I've been getting through my screws and I think I overused the short screws. So note to self, maybe in situations where you can afford a longer screw, use a longer screw, or just buy more shorter screws. Either or, really. But worth having one of these little screw organizer boxes, because it's so much easier to grab screws than out of the little sorting pockets rather than trying to pick them out of plastic bags and stuff. So I'll just check the lengths of these medium-sized screws. Okay, so these medium-sized screws can definitely both go in without bottoming out on each other, so that's what I'm going to use to attach these on. I'm going to use the medium-sized screws, and I think I'll just start with the bottom plate. I'll just sort of preload a few screws into it, and then I'll just go around and get all these legs bolted on. Oh wow, look at this thing. Isn't it magnificent? That's epic. I can't believe that with just a 3D printer and a bunch of screws and some servos that I could actually print this whole thing in my house. This is cool. Oh man. That's about all I got time for today. This is the all the mechanical stuff. I'll be making another video with the electronics, obviously, and then there's gonna still be the gel turret, which is gonna be on top here, and obviously I'm gonna have to design that myself because the original design for this hexapod base doesn't have a gel turret, but mine certainly will. Please let me know in the comments if this is a cool thing that you want to see more of, or if it's just, you know, maybe it's boring. I don't know. Let me know, and for now, that's all I got for you. Thanks for watching. Hopefully this has been educational or something. Hey, this has been educational for me. If you guys are new to 3D printing, you've just got a 3D printer, you want to learn some electronics and that sort of thing, you want to project to take on, I recommend this. I highly recommend this. All the stuff's open source. It's all on the internet. You can download all the plans and everything. So yeah, I get on it. This is awesome. And maybe we can do battle one day. All right, peace.